Hello students, how are you doing today? In this lecture episode, we are going to take a look at the concept of sine, cosine and tangent of angles. Sine, cosine and tangent of angles. And as you can see, we have a triangle over here, and that tells us that we are going to be working with triangles. So for this particular lecture, we are discussing a part of trigonometry, and this is very important for your junior WAEC exam as a JSS 3 student. Very important for your junior WAEC exam, even your exam for this term, because this is second term work. Alright, so we shall go straight into the concept of sine, cosine and tangent of angles. What's the meaning of sine? What's the meaning of cosine? And what's the meaning of tangent? Alright, now I'm going to draw a triangle again, and with that triangle I will explain what we mean by these three words. Now this is a right angle triangle because we have a right angle there which is 90 degrees, so that tells us that it's a right angle triangle. And now, what is the peculiarity of a right angle triangle? A right angle triangle is a triangle that forms the 90-degree angle right there. It forms the 90-degree angle, and it has three sides. Of course, that's why it's a triangle. Alright, so now you see, for every right angle triangle we have one 90 degrees, and then we have two other acute angles. An acute angle is an angle that is less than 90 degrees. So we have one 90 degrees, and then we have two other acute angles. Now you see that every triangle, for every right angle triangle that you are drawing, the length of every side, let's call this side A, and let's call this side B, and let's call this side C. You will discover eventually that the length of each and every one of these sides at every point in time depends on the angles. You may be wondering, how does the length depend on the angles? Now let's do a simple illustration. Now this is a simple illustration we're going to do. We are going to draw a right angle triangle that we have one of the base angles to be 30 degrees. So one of the base angles will be what? 30 degrees. And that will be something like this, which we are having. So that will be something like this. Now this right angle triangle, we are going to divide it into three different portions. And this will be the first portion, then the second portion, and the third portion. Now each of them has a 90 degree inside of it. That tells us that we're having three right angle triangles. 1, 2, and 3 right angle triangles. Alright, now why are we doing this? I'm doing this to show you the relationship between the sides of a triangle and the angles inside the triangle. So we're going to make use of this angle. For example, this base angle, which is what we said, this base angle is 30 degrees. So we'll make use of that. So imagine if we had increased this angle to 45, so it becomes like this, 45 degrees here. So this is the second case. Imagine if we had increased the angle to 45 degrees. Now you can see that the distance between here and here, the distance between these two lines, and the distance between here and here will depend on the size of these angles. It will depend on the size of the angle. So you can see that the greater the angle, the more the triangle tends to open up. So if I also extend the angle, increase the angle rather, and I make it 60 degrees. So it goes something like this, and I make it 60 degrees. You see that, you can see, because the angle has been increased, the distance between here and here will also increase. And guess what? If the distance between this very line and this very line is increasing, what do you think about their meeting point? Good. I want you to start thinking. So if we had something that is just having, because the angle is small, so we see that side, this very side and this very side, they are close to each other. It means that they will get to a point where they can easily close up here with just a short line. So it means that means the size of this angle actually determines the length of this line. I hope you are thinking. Yes, the size of the angle actually determines the length of that line. And not only that, the length of that line is as a result of what? We join this very line and this very line in such a way that it comes to a point where they can meet. If this one is here and this other one is here, can they ever meet? They cannot meet. It will not form a triangle, a right angle triangle. So it means that the length of this line is determined by what? How far this one goes, and then this one has to meet it up. You can see. So if it's going like this, you can see that the length will be what? The length will be increasing. That's exactly what we're having in this diagram, which we have here. So now let's come back to our major diagram and let's take a look at it. So coming back to our major diagram, we're going to observe this. Coming back to our major diagram. Now you are going to see that very line is smaller than the length of this very line, and it's also smaller than the length of what? Of this very line. But this one is a side of the triangle. This one is the another side. This one is about the other side. Of what triangles? We know we have triangle 1, triangle 2, and triangle 3 inside the same shape. So what made triangle 2? I think we have to give them names so that it can be easy. Now we're going to call this side A. So what made the A2 bigger than A1, and what made A3 bigger than A2? Why? Simply because the length of this line was increasing. The length of this line was increasing, as well as what? The length of this line had to follow up. Now you can see that there must be a relationship between the length of the sides and the angle, and that boils down to what? The angle that we have here. So if this angle is increasing, it means that the shape will be opening up like this. To be opening up, and when it's opening up, it means that the distance between this baseline and this is going to be increasing. And when that is increasing, it means eventually this side is going to be what? It's going to be increasing. And furthermore, if we increase the length of one side, it must definitely affect the length of the other side. Alright, now I've explained that to simply tell you this. So the information here now is that the angle which we can call theta, the angle of a triangle, has a relationship with the sides of the triangle. And the way mathematicians describe this relationship is in the form of saying sine of the angle, cos of the angle, or tan of the angle. This is the way mathematicians describe the relationship between this angle and the sides of the triangle that is produced as a result of the size of this angle. Because we have seen that different sizes of angles produces different lengths of sides, right? Yes, different sizes of angle will produce different lengths of what? Of the opposite side of the angle. Yes, the opposite side of the angle. Then the other two sides depends on how big we want our triangle to be. Good. Now, if I want to describe the relationship between an angle and its opposite side, an angle on the opposite side of a triangle, how do I describe the relationship between a particular angle and the opposite side? This description must be in ratios. What did I say? This description must be in what? It must be in ratios. And mathematicians have discovered that whenever we relate the opposite side of a triangle to another side which is referred to as the hypotenuse, whenever we relate this in a ratio, it's always as a result of the sine of the angle. Yes, so whenever we study that angle in a sine way, so we see sine of that angle, it always affects the ratio of the opposite of that triangle to the hypotenuse. You understand? Good. And then they also discovered that whenever we study the angle in a cosine way, it will affect what? The ratio of the adjacent side of that angle to the hypotenuse. So if we are describing a particular angle in a cosine way, so we say cos theta, we're trying to define cos theta based on how it has affected the sides of the triangle, and it will affect two sides of the triangle, right? Good. So we say adjacent side over hypotenuse. So if we study the ratio of the adjacent side to the hypotenuse, it will always result to the cos or the cosine of that very angle that we are studying in the triangle. Then if we now want to see how the angle relates with what the opposite side in a ratio with the adjacent side of the triangle, we'll say we are studying the angle in a tangent way. So we say tan theta. Tan theta gives us what? The opposite over what? The adjacent. Hope this is clear. So we're going to go into some little details so that you can see these different sides practically on the triangle, and you can also know how to spot them out easily. Alright, now again, drawing another triangle for the purpose of illustration. And that's our 90 degrees. So drawing another triangle here for the purpose of illustration, we are going to select this very angle. We're going to select this very angle for our study. So we want to study this angle. We call this angle theta. We want to study this angle and see how it affects two different sides of this triangle at a time. How it affects the length of any two different sides of this triangle at every given point in time. At every given point in time, we will see how it affects any two given sides, right? Because if it affects two sides, it will definitely affect the second side, the third side rather. That's what we have seen from the explanation above. So if we increase the length of in fact even one side of the triangle, it must definitely affect the length of the other ones.
You have to note this. You have to note that the sine, the cos, and the tan, which are trigonometric ratios in trigonometry, they actually show the relationship, like what we are explaining, the relationship between any two given sides of a triangle, how they relate with each other based on ratios. Based on what ratios? So we cannot put aside this term ratios. So these ratios must be involved. Now we have three different sides as we have seen so far: side A, side B, side C. So I'll use this for another illustration. Now, if you are observing this angle, right, we see that if you want to see the ratio or the relationship between, if you want to see the ratio of what side B over C, that is, when B is increasing, how does C also increase? Because we cannot increase B without necessarily increasing C, because for B to increase, it means that this line has to go higher. It means that this line has to what? Go higher. For this line to go higher, then B will be increased. And when B is increased, it means that C definitely has to come out to complete it. So you can say that B cannot change without C changing. So it's more or less like a relationship. You can see it now. So when we want to show this relationship in terms of ratios, how two sides are related to each other in terms of ratios, we study them using sine, cos, and tan. Good. Now, if we are trying to study how the opposite side of a triangle relates with the adjacent side, so that even if we increase the shape of the triangle, in as much as we are having the same angle, so the angle does not change, theta remains theta. If the angle does not change, we want to see how the opposite side will be relating with what the adjacent side, even as we are increasing the size of the triangle. So that means that even if we change the side of the triangle, the ratio will always give the same thing. So if we change the size of the triangle and then we are now having B1 and C1 as a new length, the ratio of B over C will still give us the same thing as B1 over C1. And if we increase it further, we are having B2 over C2. It should give us the same ratio. I hope you understand. It should give us the same ratio. So, and when the ratio of the opposite to the hypotenuse does not change, that is, when we have opposite, remember we said sine is the one that studies what? Opposite over hypotenuse. So when this opposite over hypotenuse remains constant, when the value remains constant, regardless of the size of the triangle, if we have different sizes of triangle, this is one size, we're having another size, we're having another size, but one thing is common: the angle is the same. if the angle is the same, it means that the ratio of opposite to hypotenuse will be constant. That is what we refer to as sine theta. So that's what we refer to as sine theta. And then for cos theta, being that this angle is the angle we are studying, so cos talks about what? Adjacent relating with what? Hypotenuse in a ratio. That is adjacent over what? Over hypotenuse. That's cos. Good. Now this adjacent over hypotenuse will always remain constant in as much as the angle is the same. And when we are observing this, we call it cos theta. Whenever we study this, we study the way the adjacent and the hypotenuse remains constant for the same angle, even if the size of the triangle is increasing or decreasing, in as much as the angle is the same. When we are seeing the way adjacent relate with hypotenuse in a ratio such that it remains constant, we call it the cosine of that angle theta. And then when we are now studying the way the opposite relates with the adjacent, so you can see that even when we increase the size of the triangle, the ratio of opposite to adjacent is still remaining constant in as much as the angle does not change for that particular triangle. We say we are studying the tangent of that angle. So the tangent of the angle therefore shows the relationship between the opposite side of the triangle to the what? Adjacent side in a ratio, shows how they relate with each other in a ratio, and they give a constant value regardless of the size of the triangle. Hope you get it now. So this is what sine, cos and tan actually talks about. So when we bring them together, we can then evaluate sine of, for example, sine of 30 degrees, cos of 30 degrees, tan of what? 30 degrees. So we can now evaluate sine, cos and tan of any angle. This actually means exactly what I've explained,
so that we can still form a right angle triangle. Hope you understand. So we want to see the relationship between this angle and two sides. So now we're going to name these sides of the triangle. First of all, I'll call here x, I'll call here y, and I'll call here z. So we're going to give x, y and z names. We're going to give them according to their positions relative to this very angle theta. Now what do you think we will call x whenever we consider this angle theta? Whenever we consider this angle theta, what are we going to call x? X is the side that is what? Opposite. So x is what? Is opposite to angle theta, right? Good. Now what do you think we'll call z? You can see that z is sharing, in fact z is touching angle theta directly. Look at it. Z is making contact with angle theta here. Oh, all right, so you can see it now. Good. Now that side that is making contact with angle theta, we'll call it a particular name. But before I give that the name, so that you will not get confused, I want to show you how to find the hypotenuse. Now whenever you see a right angle triangle, look for this sign. That is the sign of the 90 degrees. And then look at the opposite of that sign. The opposite of that sign is what we refer to as the hypotenuse. So we say y is what? Y is the hypotenuse. I'll spell it in full so that you can get the spelling. So y is the hypotenuse because it's the side opposite to the 90 degrees. Now if y is the hypotenuse, it means that the other side which is making contact with the angle is the adjacent. So we see z is what? Z is adjacent to the angle. Z is adjacent to the angle. Good. Now this is how to know the size of the triangle so you don't get confused again. The hypotenuse is the longest side of the triangle. The longest side of the right angle triangle, that's the hypotenuse. And it's always opposite to the 90 degrees symbol. Then the opposite is simply the side that is opposite to the angle you are studying. So it means that this opposite and this adjacent depends on the angle we are studying. Alright, so I'm going to draw the same triangle, but we're going to study the second angle, the second acute angle, and you see that the opposite and the adjacent actually depends on the particular angle we are studying. Alright, now we have a different triangle here. It's also a right angle triangle, but this time around we are studying this angle. We are studying the second acute angle, because I said there are two acute angles in a right angle triangle. The first one we studied was the first acute angle. This is the second acute angle, and then we have one right angle triangle, which is this. Sorry, one right angle, 90 degrees. Right angle is what? 90 degrees, and it's shown with this symbol. This symbol. Good. Alright, now we are studying the second acute angle. Now, while studying the second acute angle, what will be the value of, what will be the name of x, y, and z? What will be the name of what? X, y, and z. So again, we'll start from the opposite. The opposite is always the one that is opposite to what? The angle we are studying. Now, z becomes what? Z is opposite. So if you have been confused and you don't know how to identify the opposite, hypotenuse and adjacent before, after watching this video, you should not have that problem again. So Z is now the opposite because the angle we are studying have changed to the second angle. So it means that the side that will be the opposite always depends on the angle we are studying at that point in time. Now, what is the hypotenuse? The hypotenuse is always the side that is what? That is opposite to 90 degrees. You can even touch it. You can touch it. You can touch this point, this vertex, and then you draw it up like this. So you draw it up like this. What side is opposite to it? Y. You can see it. So for that reason, we'll say that y is what? Y is the hypotenuse. This is the short form for hypotenuse, HYP. We say that y is the what? Hypotenuse. Now, what then is x? You can see that side x is making contact. Side x is making contact with what? With the angle at this point. Now, the adjacent always makes contact with what? The angle. But it makes contact with the angle on one side, and the hypotenuse makes contact with the angle on the other side. That is why you have to identify your hypotenuse first. Then, once you have identified the hypotenuse, the last side is always the adjacent. So we say x is what? X is adjacent. So the last side is always what? The adjacent. Good. Then lastly in this episode, I will show you how you can recall the relationship of sine, cosine, and tangent. So how do we know that sine is opposite over hypotenuse? How do we know that? So I'll teach you how you can easily recall that. So it's not everything we actually need to get. We have to maybe cram or memorize, but there are some things you just have to memorize. Something like this. Now, so katwa. This is how you do it. S stands for sine, C stands for cos, and T stands for what? Tangent. So it's more or less like a mnemonic that you can use to remember the relationship between the angle and two sides of a triangle. Now, O stands for opposite, H stands for hypotenuse, A stands for adjacent, H stands for hypotenuse, O stands for opposite, and A stands for adjacent. Now, this simply means if we have sine, cosine, remember that cos is also called cosine, and tangent is also called tan. So we have sine, cosine, and tangent. It means that whenever we are studying the sine of the angle, we will be showing the relationship between the opposite and the hypotenuse. So it comes exactly in the order it is here: opposite first over hypotenuse. And whenever we are studying the cosine, it will be what? Adjacent first over hypotenuse. Good. And whenever we are studying the tangent, it will be what? Opposite first over adjacent. Good. So when you have been able to do this, and our adjacent is z, so sin theta will be what? Opposite, which is x, over hypotenuse. Hypotenuse is y. And then cos theta will be adjacent, which is z, over hypotenuse, which is y. And then tan theta will be opposite, which is s, over adjacent, which is z. So this gives us the relationship between sine theta, between the two sides of the triangle that produce sine theta, the two sides of a triangle that produce cos theta, and the two sides of a triangle that produce what? Tan theta. Now you can also find the value of theta by now taking the sine inverse. So if you have to find theta here, you now take the sine inverse. Sine inverse is like saying x over y divided by sine. So sine inverse of this, and then for cos, you find the angle by saying cos inverse of this. There's actually a function in your calculator to do this easily, so you don't have to get worried about that. And then we have tan inverse of what? X over z. So this aspect of trigonometry is very, very simple, easy and wonderful. Alright, so we're going to solve some questions in it on this, and also do some little more explanations in our next episode, possibly other coming episodes. So do well to subscribe to this channel and click the bell icon so you can get notifications. Then also like the video and share with your friends. Until our next episode, see you. Remember that Jesus loves you and is coming again. Alright, stay blessed. So you take this for your assignment. As you can see, we have 4 diagrams here. Diagram 1 to 4. Now the purpose of this assignment is to help you to be able to tell if you can now identify the sides of the triangles, as I've explained, the opposites, adjacent and hypotenuse, to see if you can now easily identify them. So once you can do that, you will now be enjoying solving trigonometry questions that has to do with sine, cos and tan. So you are going to experiment it with this. So for the 4 diagrams, you are going to write an expression for sine theta, cos theta and tan theta. Now do well to submit the assignment to the group chat, and the link to the group chat is in the description. Do well to submit it within 3 days of the upload of this lecture, so that it can be marked. Because we are measuring and trying to see how we can get the best students who performs very well in participating in this lecture, watching the videos and submitting the assignment, so that sourcing can qualify for a monthly award or award for the month. So please do well to submit yours on time. Until our next episode, stay blessed.